All right, guys, I just wanted to do a few more examples. I know this is a little bit of a complicated section. So still we're on the same worksheet 2.2b. These are some of the examples that were on there, the ones that you're not assigned. So again, we're going to go through the steps. So remember part A on this section asks us to list each real zero and its most multiplicity. So for x squared, the zero would just be 0, and because it's squared, its multiplicity is 2. For the next factor, x minus 2 cubed, 0 would be x equals 2, and its multiplicity would be the exponent, right, 3. For our next one, x plus 3 squared, our 0 is x equals negative 3, and because it's squared, our multiplicity is 2. Okay, and then if you remember part B, it asks us to determine whether the graph touches or crosses at each x-intercept or at each 0. So at 0, it has an even multiplicity, and remember an even multiplicity is going to touch. So it's going to touch at 0. So that means the x-axis is going to touch and turn once it touches the x-axis. X equals 2 has a multiplicity of 3. So it's going to cross the x-axis at 2. And then we have a multiplicity of 2, which is an even degree again, so it's going to touch at negative 3. Okay, so let's get back to my pen here. Okay, so part C is asking us to, I gotta remind myself, determine whether the leading coefficient of the polynomial is positive or negative. No, if I'm reading the wrong one. Find the y-intercept and a few points on the graph. We are actually going to skip the few points on a graph, but we are going to find the y-intercept. So remember, to find the y-intercept, we have to plug 0 in for x, because anytime you have a point that is a y-intercept, x will be 0. So we plug in 0 for x, 0 squared, 0 minus 2 cubed, and 0 plus 3 squared. But right away, I should have known when there's a 0 out front, if I multiply all of this by 0, it's going to equal 0. So it's going to cross the y-axis at 0, 0. Okay, part D says determine the end behavior. So remember, to find the end behavior, we have to first find the degree. And the degree of our function up here, since this is in factored form, we have to add up all these exponents. We have to know how many times x is being multiplied together. So 2 plus 3 is 5, and 5 plus 2 is 7. So this has degree 7. And then if we look out front, our leading coefficient does not have a negative on it. It's just a 1. So I guess I can say our leading coefficient is 1. And because that's positive, so we have an odd degree and positive, we think of x cubed, right? So this end will be down and this end will be up. We don't really know what's going to happen in the middle yet, but that's what the ends are going to do. Okay, part E says sketch the graph. So we're just putting everything together that we just found. First thing we want to do is put our zeros, our x-intercepts on the graph. So there's one at 0. We'll get a different color here. Let's try red. So we have one at 0. We have one at positive 2. So right here. And we have one at negative 3. So there's my x-intercepts. Again, those are the same as the zeros that we found in step A. Next thing we actually want to look at is the degree, so we can look at our end behavior. I know that this end is going to end up down, and this one will end up up. Now I'm just going to come, I know I have to either touch or cross at each of these, so since this end is down, I'm going to come from the bottom. At negative 3, it's going to touch, so we're going to come up and touch. We're not going to go through the axis, we're just going to touch and turn around. The y-intercept is the same as this x-intercept, so it's just going to come back up. It does say it's going to touch again at 0, so I know it's not going to go through the axis. And then it's going to cross at 2. So it's going to cross here and come up and end up right there. So that's how we sketch the graph. Okay, so let's try one more. So there is a slight difference on some of these. So let's look at number, let's say 59. So on 59, our function is given in standard form. It's not factored form. So because of that, we can't see where our zeros are. So we're going to have to factor this in order to find them. So the first thing we want to do when we're factoring is we want to find the greatest common factor. So 48x to the 4th. Okay, so here's my function. Again, it's not in factored form. We don't have those parentheses, right? So I can't just look at this and see where my zeros are. In order to see where my zeros are, I need to factor this. So if I look at 12, 36, and 48, they all have 12 in common, so I know that I can pull a 12. I have at least 4 x's in all terms, so I'm going to pull out 12x to the 4th and see what's left inside. So if I pull out 12x fourth from 12x to the 6th, I'll be left with x squared. 36 divided by 12 is 3, so this would be minus 3, and I would just have 1 x left if I took 4 out front. And 48 divided by 12 is 4, and I took all the x's. So here's what's left inside. So now this piece right here, we need to x factor. So a is 1, and c is negative 4, so if I multiply those together, I get negative 4. b is equal to negative 3, so I'm going to put that right here. Remember, I'm looking for two things that multiply to negative 3, and negative 4, and add to negative 3. So that would just be negative 4 times 1. Negative 4 times 1 is negative 4. Negative 4 plus 1 is negative 3. So let's go ahead and write that in factored form. So I still have that 12x to the 4th out front. This middle piece is going to become x minus 4 times x plus 1. So now I can go through my steps. I can find my zeros. Remember, if I just have an x out front here, it will just be 0. And because it's to the 4th power, its multiplicity is 4. My second one, x minus 4, my 0 would be 4. It has multiplicity 1, so I don't really need to write it. You could if you wanted to. And for the last one, we have x equals negative 1, also with multiplicity 1. Part B asks us to say whether we're touching it or crossing at each of these zeros. So because 0 has an even multiplicity of 4, it's going to touch and turn back around when it touches the x-axis. The other two are going to cross. So it's going to touch at 0, and it's going to cross at 4 and negative 1. Part C, we need to find the y-intercept. So we plug 0 in. We can plug it into this top form or this factored form. You'll get the same thing either way. Because each term has an x in it, if I put a 0 in for each of these, I know the whole thing is going to 0. So the y-intercept is at 0, 0. Part D is asking us to find the degree and the end behavior. So our degree is 6. Remember, depending on which form our function is in, we need to think about how we find the degree. So if it's in standard form, like we began with, we can just look for the highest exponent, which is 6. If it's in factored form, we have to add up how many times x is being multiplied together. So we have 4 here, plus this one, plus this one, so 6, either way. Remember, the other thing we need to look at is the leading coefficient. In other words, the number in front, which is 12. In both forms, it's the same. And because it's positive, okay, I know that it's going to behave a lot like x squared. Remember, x squared, I'm going to put that over here, is just a U shape. If it's positive out front, both ends go up. So degree 6 will have the same end behavior because it's also even, and because it's also positive, we know it's up and not down. So both ends will be going up like this. So last thing we need to do is just sketch the graph. So here's my axis. And remember to start by putting your x and y intercepts on the graph. So I'm going to change colors here so you can see our graph a little better. Alright, so my zeros, or my x-intercepts, are at 0, and 4, and negative 1. And my y-intercept is 0, 0, so again, that same point. I know my ends are both going to end up, so the first thing you want to draw on after you put your intercepts is what your ends are going to do. And then just look at my part B. Is it going to cross or touch each of these? So at -1, it's going to cross. I know it's got to come back up to this next one. I don't know how deep this goes, but that's okay. We're just doing a quick sketch. At 0, it's going to, it's going to touch instead of cross. So it's going to come back down again. And then it's going to come up through our last one and cross again. And that's what our graph would look like. So I hope this example and the previous one will help you guys with that assignment a little bit. If you have more questions, don't hesitate to contact me through email, and then if you need to, we can set up a conference call and we can get all your questions answered. So good luck, guys. See you later.